Hi, I'm Bradley Barth, Senior Reporter with SC Media here at the RSA Conference in San Francisco. And with me is Chris Olson. He's the CEO of the Media Trust, a website and mobile app security and data compliance company. And today we're going to be talking a little bit about the dangers of unmanaged third-party code and the important role that it's played in some of the significant attacks that permeated the news in 2018. Chris, thanks for joining us today.
Thank you for having me.
So let's get right into it. Unmanaged third-party code, explain a little bit about what you mean by that and why has that become such a significant problem?
So one of the most important phenomenons in cybersecurity over the past decade to 15 years is the migration from a predominant World Wide Web of owned and operated source code to predominantly third to nth party code. The way that manifests is that roughly 15 years ago, 80% of the source code that would render on a consumer when they visited a website or a mobile app was actually written by developers that worked for the enterprise. And application security practices did a great job in securing that code. It also left a small window for bad guys to utilize or leverage third party to put code onto different devices. Today that's changed, where the World Wide Web is roughly made up of 90 to 95% third-party code, but application security hasn't changed. Enterprises today still assume that their websites or mobile apps are safe because they utilize core application security products for that owned and operated, where in reality that's covering maybe 10-15% of the site, and a significant portion is third to nth party. That's where the bad guys play.
So let's talk about some examples from the last year or so. Let's start with Eve, that's 3VE, and that was a major ad fraud network that was fueled by a botnet. There was a big FBI crackdown on that actually last year, but without third-party code, that whole operation may never have happened. It was played a very integral role. So explain sort of how the third-party code was the origins of that scam.
So that's a great example of how the world looks at cyber. And first, kudos to Google and White Ops and the FBI for that great takedown. But what's interesting about third-party code is that it is actually what is leveraged to create the bot in the first place. The predominance of the industry doesn't look at these attacks this way. They're focusing on bot attacks right of breach. The original propagation of that bot, the building of it, was done by consumers visiting major websites that are predominantly made up of third-party code. Third-party code was being leveraged by bad guys to put source code onto the devices that then ultimately were sold to the highest bidder, and in this case became Thrive and MethBot and other types of bots. What I'd also want to underscore there is that ad fraud is often the concept that security people like to use when thinking about third-party code. It's all about bad advertisers and the ad ecosystem being a bad place. That ad fraud bot could have been used to execute DDoS attacks or other types of security issues. So ad fraud is often an excuse to not pay attention to the problem, and you can see the manifestations of that today.
Another issue, and this has been going on for a few years, but it really seems to have risen to another level of severity in the last year, is MageCard. MageCard, of course, is a payment card skimming attack that has been plaguing a wide variety of websites. Some of the prominent victims recently have been Ticketmaster and Newegg and British Airways. And again, third-party code playing a role in that. Explain how.
So first of all, credit card skimming has been around for years. It does seem like 2018 was the year that became a high-profile problem, in part because some very significant companies were named. But this is something that's been happening for a very, very long time. Those three companies that you mentioned are certainly not the only to be impacted by this. It's actually quite prevalent. But it's a great topic when looking at how third-party code works, and that enterprises are typically not reviewing it. So within the purchase funnel on today's websites and apps, there's obviously the owned and operated source code, but there's also leased mechanisms, for example, credit card fulfillment, other types of knowing who the consumer is, addresses, shipping. All of that is typically done via third parties. Those third parties reside on the web pages as they render on the customer's device, and they are not monitored by traditional application security. So enterprises need to be paying attention to those because the bad guys are manipulating that third-party code. In the case of credit card skimming, enabling a redirect out to source code that overlays where credit cards are typed in. The really neat thing about MageCart is that it actually used marketing third-party code to then drop cookies so that after the consumer initially entered a credit card, the cookie dropped, they hit update, and the next time the page loaded, it moved the bad code away and the consumer just made the purchase so that no one actually knew what was happening. When we talk about being aware of the issues in third-party code, it extends past the enterprise as well. In this case, it underscores how the PCI compliance groups that set those standards are quite asleep at the wheel, and they're not paying attention to what really needs to happen in today's new environment.
And the third and final example we'll talk about is the Cambridge Analytica scandal, which obviously caused a lot of controversy with Facebook. Facebook having a third-party partner who was collecting data that perhaps Facebook wasn't aware exactly what they were doing with that data, and there were obviously a lot of privacy implications there. Again, explain how third-party code, unmanaged third-party code ties into this.
So Cambridge Analytica is one of our biggest news stories around data compliance and data leakage, which ultimately come back to third-party code and also ultimately come back to knowing who you do business with. So in digital, the core concept of having secure digital assets should mean that if an enterprise is inviting 10, 50, 100 different companies to render source code on me or within an app structure that I'm in, and I don't have, as a consumer, I don't have any control over what's happening to my data, it is incumbent upon those enterprises to at least know the companies that they're allowing to render or that they do business with, to know what they're going to do with our data, and in a trust but verify situation, make sure that they're monitoring that they're following all the policies that they have.
All right, great. Well, thanks, Chris. That was Chris Olson from the Media Trust, and I'm Bradley Barth, Senior Reporter at SC Media. Until next time, have a safe day online.